Christians talk about the age of the earth, there's kind of two broad categories of people. There are those who believe that the earth is 6,000 to 10,000 years old. There are those who believe that the earth is 4.5 billion years old, as the science seems to indicate. Question is, what are some of the strongest scientific evidences that the earth is indeed billions of years old?
Well, I think one of the simpler ones is just the sheer quantity of biodeposits that's in the crust of the earth.
Biodeposits would be oil, coal,
limestone, concentrated metal ores.
These are things that are the remnants of life that is decayed and deposited somewhere.
Either
correct?
that or the result of the activity of life, past life on planet Earth. And we've done an inventory here at Reasons to Believe that shows that there's a minimum of 76 quadrillion tons of biodeposits in the crust of the Earth.
I presume that's more than animals and plants could produce over the span of a few thousand years, correct?
Exactly. You're going to need millions of years, even with all the plant and animal life on planet Earth being at the maximum possible abundance, taking the sun's energy and converting it with the maximum possible efficiency into these biodeposits.
So you can put hard limits just on some calculations.
You can put very hard limits, and that's something we've done at Reasons to Believe, showing that there's no way you can fit all of the Earth's biodeposits into that short of a time frame.
So what else? So what else is besides the biodeposits?
Well, another easy one is you look at the planet Earth, and the short-lived radiometric elements are missing.
So these are radioisotopes, elements that decay from one element into another.
Yeah, for example, plutonium. There's no plutonium, natural plutonium, in the crust of the Earth. And plutonium has a half-life of 88 million years, so it's decayed away, which means that the Earth.
So we could produce it in our nuclear reactors, but there's none left. So the fact that it's a few million or tens of millions of years and it's not here anymore means that it's all decayed away. The original amount has all decayed away.
Well, plutonium would still be here if the Earth was a billion years old. The fact that there's no plutonium left at all means that the Earth must be much older than a billion years.
Okay,
and that's just one example. There's no Neptunian either.
Yeah, I think technetium is another one that there's no naturally abundant.
Right.
Okay, so the radioisotopes, you've got the biodeposits, the radioisotopes. What would be your third strongest argument that the Earth is billions of years old?
Well, again, for the layperson, I would say the ice cores, because we've got deep ice core drills in Antarctica and northern Greenland, which show as many as a million annual layers of ice.
And so this is where you've got different layers of snow coming down, and so you can actually record, kind of like tree rings, varves, other deposits that you can count. We actually have histories where these date well into the tens of thousands, even hundreds of thousands. I think the ice cores go almost back to a million years.
They go back to a million years, that's correct. And we can prove that they're annual layers because you actually see the dust signatures of volcanoes that have erupted in human recorded history.
So where we can tie them to recorded history, they do indeed match that these are annual layers.
These are annual layers. Moreover, you can actually see in the deepest of the Antarctic ice cores 10 cycles of the variation in the eccentricity of Earth's orbit.
And that takes, how long is the eccentricity, or how long is that cycle?
It's a 100,000-year cycle.
100,000-year cycle. So we've got easily hundreds of thousands of years then in these ice cores.
That shows that you've got a million layers of ice there, and it's all based on celestial mechanics.
Yeah.
Newtonian mechanics tells us that Earth's orbit varies in its eccentricity with a 100,000-year cycle. The fact that we see 10 such cycles means that definitively a million years.
The fact that it correlates with how many layers we can count is pretty remarkable, too.
It is.
It really does say that we live on an Earth that is quite ancient, well into the billions of years.